All right, everybody. In this video, we are going to see where earthquakes typically occur. This is the picture of plate configuration of the Earth. I think you have seen this before, but most earthquakes occur along what we call as plate boundaries. So, for example, this is a Pacific plate right here, and the plate boundaries are the ones that are represented by these thick black lines along the perimeter of the Pacific plate in this case. Okay, so I want you to pay attention to these black um, dash lines that we have along the Pacific plate perimeter, and these are the sites where these red dots represent earthquake epicenters. And as you can see here, most of these red dots fall along what we call as plate boundaries. Okay, so there's a strong relationship between plate boundaries and earthquakes. And we have learned so far that we have three types of plate boundaries: convergent, divergent, and transform plate boundaries. And earthquakes can happen in all types of plate boundaries. However, something that you need to know is that some of the plate boundaries will produce much bigger earthquakes. So, for example, convergent plate boundaries, where we have two plates colliding with each other, this is a good example where big earthquakes, will be generated. Because you can imagine we have two gigantic plates that are colliding with each other, which is a really good recipe for big earthquakes to happen. Okay, so earthquakes will happen along the trench where this is the site where it collides, where the two plates collides, or it can also rub against each other at depth here. This would also be part of the earthquake zone within convergent plate boundaries or within subduction zone. Okay, so remember that earthquakes happen along faults, and the type of faults that could happen along plate convergence is called the reverse fault. A reverse fault is when you have a block that climbs upward due to compression. Okay, and this is world seismicity right here, and I'm going to show you some of the major earthquakes that happen on Earth that have a magnitude above 6. So many large earthquakes occur along subduction zones, and as you can see, here are the subduction zones that we have along the Pacific plate, for example. Okay, along the perimeter of the Pacific plate, here are the some examples of subduction zones right there. And then some of the great earthquakes are related to the mega thrusts along the subduction zones, represented by these yellow circles. Convergent plate boundaries are also great places for earthquakes to occur, and not only that, it can also produce deep earthquakes. As you can see here, this blue circles that they actually go down to 600 kilometer. Okay, and convergent plate boundary is the only plate boundary that can generate very deep earthquakes, and this is the zone of earthquakes right here, and this zone is called Wadati Biniev zone. Okay, the second example for a type of plate boundary that could generate earthquakes is definitely transform plate boundaries. So motion along transform plate boundaries can cause many large earthquakes. Remember that transform plate boundaries, these are the sites where we have two plates that are moving horizontally, as illustrated by this picture right here. We have this block going upward and then this block going downward. So they're basically, the two blocks are rubbing each other along this fault zone right here. This is called the transform fault or transform plate boundary. Okay, the example would be definitely here is the San Andreas fault that we have on the western part of the United States right here, as illustrated by this picture on the left. Okay, and again, earthquakes will be generated along a fault, and the type of fault that we have in San Andreas fault is called the strike slip faults right here. This is because we have the two blocks that slide horizontally past each other. Okay, and again, the two blocks will rub against each other along this zone right here, along this fault zone, and that is where earthquakes will be generated in transform plate boundaries. All right, the next one or the last one would be divergent plate boundaries. Divergent plate boundaries, they produce earthquakes because we would have some normal faulting that happen along these boundaries. So for example, we have present day divergent plate boundaries that are currently happening. So as we speak right now, the eastern part of Africa is actually splitting apart, okay, along this zone right here. Okay, now this is what we call as divergent plate boundaries because there's a rifting, there's a process called rifting that is currently going on in the eastern part of Africa. So what happened here is that normal faulting will start to occur associated with this rifting process, and again, earthquakes can be generated along the fault. Okay, and the type of fault that we have here is called the normal fault, when we have a block slides down a fault surface due to extension. Okay, so we talk about the three major plate boundaries: convergent plate boundaries, transform plate boundaries, and divergent plate boundaries. All of them can generate earthquakes, but some of them will generate bigger earthquakes than the others. So for example, convergent plate boundaries will produce, typically they produce much bigger earthquakes than transform or divergent plate boundaries. But of course, we also have some big faults along transform plate boundaries that can generate big earthquakes as well. But divergent plate boundaries is not known as something that could generate big earthquakes. Okay. However, earthquakes can also happen within the interior of the earth, and this is what we are going to see in the next few slides. So some small percentage of earthquakes, they can occur within the plate, okay, or what we call as the intraplate earthquakes. Okay, and they sometimes can be quite damaging, even though they're not located on plate boundaries. So for example, this picture right here, this is the United States, and all of the red dots that you see here on this map, they are all interior plates, interior earthquakes or intraplate earthquakes. Okay, so one of the most devastating intraplate earthquakes that we have recorded so far happened in Missouri, near New Madrid. Okay, and this is actually the largest earthquakes east of the Rocky Mountains in recorded history. There were 3 shocks that happened over the winter of 1811 to 1812, had about magnitude of 7 to 8, and they are very, very large, and there was a significant damage caused by these earthquakes. And one of the recorded event was actually the Mississippi River flowed backwards for short intervals after the earthquakes. And as you can see here, this map right here shows you the damage area here within multiple states in the United States right there, and the shaking can be felt as far as Wisconsin to Louisiana right here, and then Virginia up to the east, and Kansas up, to the west part of that location. Okay, so what happened here? What happened in the interior of the earth, especially in New Madrid, is that there was a reactivations of some ancient faults, some old faults. So for example, we do not have any plate boundaries in this area, obviously, because it's in the middle of a plate, but there were faults that have been buried, and these faults were very old. Okay, and there was some reactivation of some of these old faults that generate earthquakes in New Madrid in 1811, 1812. Okay, so as you can see here, these are the plots of earthquakes in this area, and this picture right here shows you some trend of some earthquakes, right? And these are the fault zone along this area. These are some of the fault zone that happen along this area right here, and some of these faults were reactivated and caused some devastating damage within this region right here. Okay, so that's all for the location of earthquakes, and I'm going to see you on the next video about seismic waves. All right, I'll see you over there. Bye bye.